So, firstly, the importance of water in the pharmaceutical industry. So mainly they in the pharmaceutical industry they use it as a directly in the product as a solvent, and for the washing, for primary washing and the final washing as in the purified water, and some this in BDs and Bs and all those things. So the water is considered as a critical utility for the pharmaceutical industry. And why we use water is that is the as you know it's a universal solvent, and it is available to the all the industries. Okay, and in particularly in pharmaceutical industry, we have typically we have we will have the four different types of waters. Like one will be the source water, and we can call it as a raw water, and that means what the water we are getting from the outside or the to the plant. It may be from the river or municipal water or the bore wells, underground water or the surface water from the lakes, nearby lakes or the by the tankers, whatever we got. Irrespective of its parameter, we call it as a source water or the raw water. It may be treated also, but as per the plant concern, it's a raw water for us. So next stage of the water will consider as the potable water. Potable water is uh, the pre-treated water. We can say we'll treat the water based on our requirement. Like potable water will use as a only in the washing, not for the solvent mixing, and that be the primary washing, not in the final wash. Okay, potable water will use in the like for the utilities and all those things. So compared to the raw water, potable water will be the quality of the potable water will be high, but not will consider as a purified water. It's just a pre-treated water. And next stage will be the high pure water, or we call it as a purified water. So the processing, the purification of this purified water process will be the very high, and we have different parameters. We can say that this is the raw water, this is a potable water, and purified water. Based on the parameters, only we call it. We will differentiate the water, which type of water it is, and based on the purification methods, and the water for injection. In the water for injections, we will sterilize the water, and the purified water we will use in the oral solids, and water for injection will use for the injectable plant. And see, the treatment process of the every plant will depends upon the water quality we are getting. Here, the water quality in the sense what the contaminations we have in the source water. Basically, in the source water, we don't have the guidance for guidance. Different guidance are not there for the source water, but based on the source water, we have to design the approved our qualification. Sorry, our treatment processes. Like based on the what if the microbial contaminations are high, we have the stringent chlorinations or ozonations, whatever. And if the chemical contaminations is high, we should have the multiple stages of ROs and treatment systems and UF, and we'll come in detail for that. But what the basic is, the purification method and the will be uh, will depend upon the source water, right? Here, see, I just want to tell you that what are the chemical and microbial parameters will be there. What are the chemical parameters? Like in water, we have the TDS, total dissolved solids. That will tell about the number of that will tell the contamination, chemical contamination in the water, like ionic contaminations. And TDS, uh, conductivity, and TDS and conductivity are both are the same, but there is a calculation difference here. TDS and the conductivity in the sense they will tell you about the contamination and ionic contamination basically. What they will do is see if the ionic contaminations are higher, the conductivity of the water will be the higher. Conductivity in the sense it's the electrical conductivity, you can say. So what we have to do is we have to remove the ionic contamination so that the conductivity should be the lesser. We have to remove conductivity should be the lesser, like in the potable water. In the raw water, suppose it's a 500 PD, 500 microsiemens per centimeter. The conductivity unit is microsiemens per centimeter. So in raw water, it's a 1,000. We can say if suppose it's a 1,000, though we have to process the we have to treat the water like that. The contamination, the conductivity should be go lesser. And another chemical parameter is a pH. pH, the purified water pH should be like we have to maintain like 5 to 7. So we have to design our treatment systems like we should maintain it at 5 to 7. And how we will design, how we will qualify that, we'll let you know. And again, pH and TOC, total organic carbon. See, we should also calculate the organic carbon in the water. Why we should calculate the organic carbon is, so carbon is a good source, a good food for the microorganism. If the organic carbon is higher, there is a huge chance of the increase in the microbial load. It's a food for the microbial organisms. So we have to control the TOC also. And the guidelines will say that it should be less than 500 parts per billion, ppb. Okay, we have we will have the online parameters and the offline parameters. Sorry, online sensors and offline QC will also test for that. So these things we have to ensure that they should be in the control. If the purified water is, if you want to say it is a purified water, the conductivity should be less than 1.3 microsiemens per centimeter. And a TOC should be 500 ppb. And pH should be 5 to 7. And coming to the microbial load, the unit for the microbial contamination, we calculate like CFU per ml, colony forming unit per ml. So it will be our limit is 100 CFU per ml. So our purified water should be less than 100 CFU per ml. So QC persons will take the sample and they will analyze it. They will give the records. Okay. Hope you are getting me.
Yeah, you can go ahead.
So as I said in the first slide, see treatment systems. These are the basic treatment systems here: chlorination, pre-treatment, purified water distribution, WF and tube sanitization. So these are the basic system. But in detail, we have the different equipments or different processing systems based on our raw water. So if suppose it's a if you say chlorination, some based on the microbial load, we can dose ClO2, chlorine, NaOCl, chlorine, sodium hypochlorite, we can say, and ozonation also we will do. Based on that, it will reduce the micro load in the raw water. Next, in the pre-treatment, coming to the pre-treatment, in pre-treatment also we have the MGF, we will have the MGF, UF. In detail, I will explain what the MGF will do, what the UF will do, why we require that, what is the other processes. As of now, I'm just telling you the broadly, like in pre-treatment, we'll have a MGF, UF, and a softener, and RO systems also. It's a pre-treatment. We call it as a pre-treatment, and in that we can have the flotation, adding of the alum for TSS. TSS is the total suspended solids. It will be removed in the MGF, and if they are in a higher concentration, we have to use some other methods like adding the alum and float and all this. And in purified water generation, the treated water from the pre-treatment will give you as purified water generation. Will give the supply to the purified water generations. Purified water generations are, we have different methods, techniques for the generating the purified water. One typical method is the MGF. One typical method is DM plant. We call it demineralizing plant. In that we have the anode bed, cathode bed, and mixed bed. DM plant is the older one, but still few plants are using the same method. And the advanced is that now we are using the RO EDI. It's a double. It will be a double pass RO and the EDI also, based on your conductivity and the EDI capacity. It will be like a single and a double pass RO. First, the pre-treatment water will go to the RO again. Then the treated water from the RO will give you to the EDI. EDI in the sense electro deionization. Electro it will charge the EDI. You will give the DC power supply. In that also it's the same like a DM plant. It will be like there will be anode bed and the cathode bed, but those will be generated by the electrically. Okay, for positive and negative charges will be there. In detail, I will explain you that there was ionic bond. As of now, we call it as a ROEDI. The outlet of ROEDI we consider as a purified water. Once it reached the, as earlier said, our set parameters, basic set parameters like conductivity, pH, and the TOC should be the within limit. So we will design the generation system like that based on the raw water and what we require at the end. So we will design and the user will write the specifications like that, that we have to treat this water. Likewise, that we have to get the purified water generation. Okay, and after the generation, we have the purified water distribution system. In purified water distribution, the generated purified water will collect in the purified water distribution. It's a loop. We call it as a circulation loop. I will show the this P&AD once we get in the detail. It's a loop. We will collect the water and distribute to the user points. The user points in the sense in the production area. But the distribution will be happening in the loop. It's a circulation loop. The pump, there will be a tank, SS tank, and there will be a pump which will be distributing the water to the user point. Again, the water will collect in the tank. And we have to maintain some certain parameters like velocity, flow, again temperature, and TOC. Again, we'll have the TOC sensors here, analyzer we can say, and conductivity sensors. All those will be there in the distribution loop. And in new approach, we'll have the ozonation loops also. We will get with that. Then again, it's a WF loop. This distribution loops, it is for the oral solids, but WFA, water for injections, will have the hot loops there. The purified water distribution loop is the ambient loops, but in the WFA we will continuously circulate the water at the above 80 degrees. There will be a jacketed tank will be there. In that we will supply the steam and we will bring the temperature up to 80 degrees and we will maintain that 80 degrees, and the loop always will be circulation at the temperature of above 80 degrees. And loop sanitation, we will cover in this also. Loop sanitation, what should be the sanitation approach and what will be the outcome of the sanitation, and what are the different techniques of the doing sanitation, and what are the process on how you define the sanitation frequency and the method. We have different ozone sanitations and hot water sanitation or the chemical sanitation. So we have 3 different methods. how we define and how we will set the frequency of the sanitation, and what is the time period of the sanitation, how much time we have to perform the sanitation, and uh, what is the outcome, what should be the after sanitation, what were expectations from this quality of the water. And again, we will cover the operation and the maintenance of the water system, like how you will maintain the, see if the, okay, we have defined the system, everything is qualified, but we have to maintain the system like that we should get the consistency of the water quality. It should not be like one day our conductivity is 1.1 and again another day it should be like 1.01. Not, it should not be there. There should be a consistency in the water quality before giving to the user point. So how you will maintain the and operation and maintain the water systems. So based on that required, what are the required parameters? As I said, these are the major, but again in relation to that, we have the few more parameters will be there. So we have to maintain the ORP, oxidation reduction potential, to ensure the removing of the chlorination, and we should maintain the in the distribution loop. We should maintain the velocity of the water, you can say flow of the water, and all those things. There are some other parameters that will help us to get the specific and consistent quality of the water. So how we will maintain, we will cover in that. And instrumentation and automation. Automation in the sense is the quality of the water is out of the specification. How we will act, how the system acts actually, how the there will be a dumping system, how the dumping will happen, what are the expectations from the auditor, what are the questions from the auditor will be there in the instrumentation and the automation process, basically. And the maintenance, if there any cleaning required, how the RO works, and how we have to maintain, what are the parameters which will sign that these are the, if the one parameter is gone higher, what should be going wrong, that we will also cover. What the equipment is going wrong, if the RO is damaged, if the conductivity is higher, as it is EDR damage or the RO damage, we should get to that. And how we will handle OS and incidents, how the investigations will be carried out, and what should be the uh, impact, what will be the impact on the batches. So based on, see, if the conductivity is high, if the yeah, suppose it's a in distribution system conductivity is higher, and definitely we'll go for the investigation, but not like that. We have to stop the entire system. We have to stop the raw water and all the things. We have to investigate thoroughly. It may be the problem with the sensor or the some cable or the actual product water quality is increased, or is there any contamination from the product side. We have to investigate thoroughly, and I will show the few uh, cases, uh, that how the investigation will be there. And alarm verifications, how you uh, identify the alarms, how you acknowledge the alarms in the water system, what will be the auditor's view on the alarms, and what their expectations from the alarm verification, and all those things we'll cover in this. And coming to this, it's a commissioning and qualification. Here in commissioning and qualification, see, what are the basically these are the different uh, steps we are going for the, before going for the qualification, steps of commissioning and the qualification. Like first we have to prepare the year. First we have to prepare the URS. As I said, first we have to give the we should know that the raw water specification. From the raw water specification, we have to know the end water, like purified water specifications. Before, in between, we have to design. And likewise, we have to give the specific that these are the quality of the water and quantity. Quantity also we should define that how much water we require. So based on that, the capacity of the treatment systems will be increases. Like we can say if our batch is very small, if it is going to the certain area, we're having the 1 or 2 user points, we can give it like one meter cube per hour, 1 kL per hour capacity of the purified water generation. If it is higher, we have to go for the big 10 meter cube, 5 meter cube, and all those things. And the cost will also impact based on that. And the detailed designing, functional specification. After user specifications, functional specification. Designing in the sense here we will come like what are the techniques we have to use in the for the purification system, whether we have to go for the DM plant, RO plant, or the some other distillation processes, or we have to what are the instrumentations we have to use, instruments we have to use, what are the interlocks we have to give, what are the sensors we have to mount, we have to give, and how we have to monitor these things, how the data will be capturing. All those things will come under the specifications, functional specification. And later we will select the vendor. Once the DQ is a functional specification is completed, vendor selections will be happening, and vendor will give us the design qualification. So design qualification is basically the counter for our URS. We will give the URS and the FS. So based on that, they will give the DQ. DQ in the sense, if I write I want 4 meter cube per hour ROADI, so they should, in design qualification, vendor should give us that same design or the even it may be a vary, but we should if there is any variation in the DQ, we have to raise the user URS deviation request. So URS is our requirement, and DQ will be like what the vendor is giving to us. After the verification DQ, we have to cross check that what our URS is saying or what the DQ is saying. You have to cross check the both. If there is any deviation, we have to write if the deviation request form, URS deviation will be there, and we have to get it. We have to get the approvals from the quality, and we have to give the specific reason why it is not meeting our requirement. Vendor DQ is not required. Vendor DQ is not meeting the URS requirement, and we have to give the justification, proper justification. Like suppose in some cases, what will be in URS we will say that I need this 4 meter cube of ROADI, but vendor will give you that 5 meter cube ROADI. They don't have the specific design, and they may give that one based on our the site consistent site scenarios. They may vary, but we have to give a proper justification. Though it is a positive change, that will impact on the cost also. So that we have to give the proper justification and get it approved by the QA and the planted engineering head. After DQ approval, the vendor will start the manufacturing of the specific specific mission, specific that we can say RO area or RO system. They will design or they will assemble. Again, before DQ and the installation qualification, we have the installation processes, and again FAT. After FAT, installation qualification will be there. Installation qualification, we will check the critical all the equipments and the components. We will verify based on the DQ they have given the installation was done as the installation was done properly, mounting was done, and all the electrical wirings is connected properly, or the components, all the sensors are given. All those things we will check in the installation qualification. In the operation qualification, we will check the alarms. If the hydro test, pacifications will be carried out, alarms will be generated, and we start the system and ensure that everything is operated as per the specific procedure or the protocol without any noise. Is our water is having the in operating, we will start the system. Is water quality is okay, and all the things we'll check in the operating procedure. And again, in performance qualification, we have 3 types of performance qualification, like phase 1, phase 2, and phase 3. In performance qualification, what we'll do is in phase 1, here we will define the sanitation approach. We can keep like we can keep that 15 days or the 1 month or anything, but we have to give the some rationals for that before setting the frequency. In the qualification, in the phase 1 qualification, we have to challenge the sanitation process. We can say, suppose it's a 15 days sanitation frequency. We have to give the 15 days. The phase 1 should be like more than the 15 days. You can give 15 days or the 30 days, but it should be minimum, like it should at least cover the one sanitation cycle or the 2 sanitation cycles for better uh, uh, data monitoring. Okay, so for first day we will sanitize the system and start the phase 1. At the 15th day, the trend, the micro trend should be the same, or the after sanitation there should be a drop in the micro trend. All those things we have to analyze. The data should be analyzed based on the summary will be prepared. So phase 1 will be like after the phase 1 system will be released for scheduled operation, but phase 2 is for the again phase 2 will be like same days as the phase 1 only, but the system will be in routine operation, but sampling will be continued. But in phase 2, again we will generate the data. Sampling will be carried out, we'll generate the data, and the sanitation approach will be finalized. Like 15 days, or we have to give, if the micro trend is higher at the 15th day, so we have to minimize the frequency. Like we have to go for the 7 days only. Likewise. So if the phase 1 is qualified, again we have to go for the phase 2. And finally, in the phase 3, all the sample points will not be covered in the phase 3. Only limited, like there will be a schedule to cover the 15 days once we'll collect the sample. And all the user point, all those things will be there. But phase 3 will be like, you have to check the seasonal verification, variations, and impact on the system. Okay. Hope you are getting me. Hello.
So yes, Shrikant, that's good actually. Just give me a second.